I wanted to share some of what we're working on in the context of nature-based solutions, which is a phrase that's received a lot of attention recently, and I think we need to consider very critically, are nature-based solutions good, and are they the right solution for the right problem in the right place? So what most of my lab has worked on, and I've spoken at other Research on Tap's events, is the carbon in decarbonization. So I'm going to just highlight it, and you could ask me about it during the on tap portion. We do a lot of work modeling emissions. This is from the New York Times last month that covered some of our work on developing greenhouse gas carbon emissions inventories. We also measure how those emissions end up in the air. And these are measurements, the black points are on the roof of CAS. And so these are measurements in Boston looking at CO2 and methane and how that carbon ends up in the air. So you could ask me about that later. That is 90% of what my lab does. What I'm really excited about at the moment, though, is some of this green space. So this is Boston. You can see Comm Ave, you can see the public garden, you could see all that green stuff. And we've been working on developing some new sensor technology to measure how water moves through plants and what that water movement through plants does to climate. So this is a little data logger, and we've inserted it into the tree, and we're measuring the water movement through the tree. So water is coming from the soil through the tree, ending up in the atmosphere. When the water changes phase from liquid to gas, it cools. And it cools substantially. So this is Arlington, town where I live, and the panel all the way on the left is a land cover map. So it's a simplified classification of what kind of vegetation you have in different parts of the city. So if you have leafy green residential areas versus areas that have spindly street trees, those areas translate into a very different climate that's experienced there. The middle panel is showing land surface temperature. This is the satellite-derived estimate of surface temperature. And you see a large spatial coherence between the amount of vegetation you have and how hot it is. And that is directly proportional to the amount of canopy cover and the surface temperature. And so we've been taking some of those measurements of water movement through trees, this sort of satellite imagery, and analysis of how hot it is where and how the vegetation relates to that, and thinking about the future in that decarbonization context and in the nature-based solution context. So this figure's a little bit complicated, but it's really cool. So shown on the y-axis is a term referred to as the Bowen ratio. It's the ratio of the sensible to the latent heat. So how much of the incoming radiation that we have coming in from the sun is being converted into heat, increased temperatures, versus being used to evaporate water. And that's that water movement through trees. If you have more sensible heat, it's going to be hotter for the same amount of radiation input. If you have more latent heat, it's going to be cooler. And so on the x-axis are model runs that we did using the Weather Research forecast model. And my colleague Dan Lee ran these, and we looked at how the amount of canopy extent that you had in Boston at 10% canopy cover, 25% canopy cover, or 50% canopy cover related to what the resultant temperature was. And that's what's in red below. So these are summer estimates during a heat wave, I'll point out. So from 34 degrees C to about 32 degrees. I'm out of time. I'm going to be fast. Trees cool. But trees cool much more than we thought they did. In these models, we assume that plants run out of water. In cities like Boston, they don't actually run out of water. And so if we release the constraints of water limitation, which we do through management, trees do a lot more than we thought they do.